Yo, what's up, everybody? Welcome back. Today we are working on trying to write a user space USB driver. For context, some of you have been following the stream for the past couple weeks, and we've been talking about this like Xbox controller, right? And the fact that he's got some paddles on the back, which is pretty hype, but the paddles on the back can only be remapped to other buttons on the front. And so if I want to do something like use one paddle to do push to talk and like another paddle to save the replay of the last thing that happened in OBS or something, like that's not something that I can do because the controller is kind of expecting that he's going to be an Xbox controller, right? And so we've been kind of exploring the idea of trying to reverse engineer this guy to change his firmware to export these back paddles as their own buttons that can be remapped by software, right? That's what we really want. We don't want them to just be duplicates. We want them to be their own things that we can interface with. And so we popped this guy open. We started like looking at this like EEPROM. We bought this like Raspberry Pi Pico, right? And he's so that we can talk to the EEPROM if we were to like desolder it. And we've been like playing around with this guy. We've been writing some Zig to replace the SDK that comes with this thing because we like to make our lives hard around here, all that type of shit. And we got pretty far. We got to the point where we can like export some I2C wire wiggles, right? We pop out the scope, we see some I2C communication happening, and we never got to the point of like actually dumping the EEPROM, and that would have been today's task. But I was thinking about this a little more, and somebody wrote in the YouTube comments, and it got like a brain worm in here that can't get out, and he's like, "This is just gonna end with you making your own PCB," and I'm like, "That just sounds more fun." Right? Because, reverse engineering, very fucking cool, right? But what's even way cooler than that is forward engineering, just making a thing, right? And it's like, what do we really need? Like, where is this going to go, right? Say we get everything that we would ever want out of this controller. We still need to like reverse engineer the whole fucking thing just to like swap out some buttons. It's probably going to be kind of hard, right? Like, this is a hard enough task doing it the normal way. Trying to add on the layer of like reverse engineering is going to be a lot of work. Enough work to the point where I think it's just easier to make our own controller, right? Like, how hard can it be? How hard can it be? I've never said that and regretted it. But like, what do you need for this guy, right? You need like, some like controller sticks. You can just buy these off off AliExpress. I just ordered some like I'm gonna Google this really quickly off the screen, but AliExpress Hall sensor PS5. I just want to make sure I don't like leak my address by mistake by doing this, right? But you can just buy these things, right? You've got like these control sticks. So this is kind of like you got the sticks, which are kind of like the hard part. Yada yada yada. We're mining our own silicon. What could go wrong? That does seem kind of in line with where we would end up. Right? But you buy these things, they output some voltage when like the magnets swing around on there. They're pretty cheap. So we buy some of those. That's kind of like the hard part. Then we need to like we need some like buttons probably, right? You want to like put all of this stuff on like a PCB. And so I was looking up like, how the fuck do other people do this? And I just looked up like open source controller, which we looked up in all caps last time because that's funny. I guess it was just on. But this has been done. Right? This has been done, and these guys have an open source controller, and it's kind of sick. And when we look at I thought it was here. Where do we? Oh, here. What do we need on here? There are like a couple of thumbsticks, some buttons, and yeah. What we found when we looked at this is that they just kind of solder a Raspberry Pi Pico onto a bigger PCB. Right? So they just have like a PCB that looks like this, and you just drop the thing that we already have onto these pads, right? And it's like, yeah, that's just a good idea. The Raspberry Pi Pico, it's like what, $7 Canadian? You just buy this. PCBs, I've heard, are like cheap as fuck to print, right? Like maybe like $5 for like a few of them. And then on this PCB, they just got like buttons and shit, right? So they got, you solder on like a few buttons, you print the rest, that you print the case, you print the buttons, and you call it a day. How hard could it be? How hard could it be, right? And so I think that if we made our own controller from scratch, it's just cooler, we have more flexibility, and we can design however we want, and it would just be more fun. And so that brings us that brings us to today, where I want to write a USB device driver. And you might say, how the fuck is any of that related? Well, eventually, like if we follow this plan, right, where we take a Raspberry Pi Pico, he's the brains for our controller, and then we solder him onto some PCB we make, eventually he's going to have to talk to the computer over USB. And I don't really know how to do that, right? I don't really know what the gamepad should behave like. And so what I want to do is I want to interface with an existing USB controller and try to like get as low level as is reasonable given what like the Linux kernel will let us have. And that way, when we start implementing the device, the USB device side, we'll have like a good understanding of what it's supposed to be doing and the tooling to be able to like customize at a very low level how we're interacting with it, so we can kind of poke and prod and make sure that it's working correctly, right? Because if we were to just try to like make USB controller, plug it in, and then it didn't work, we'd be like, right, there's a lot, where do we fucking start, right? So I want to have some way to do like incremental progress, and I think having some sort of like user space driver that we can play with is a good start. So that's the plan for today, is to try to interface with the actual Xbox controller I have on my desk, see where that takes us. We did a fair amount of reading in the past couple hours, so we've been trying to understand what the fuck is USB. We have a very naive understanding of it at this point, but it's probably good enough to start poking and prodding, right? So my understanding right now, you have your controller. Oh, look at that. We drew that shit good. We drew it good. He got a couple of sticks. He's got a little X here. Wow. He plugs in. What is the reason for not doing it as a kernel module? Just convenience at this point. Looks like Snoopy on drugs. Okay, this guy, we'll stay on topic. We gotta stay on topic. This guy plugs into some like PCI card, which might not actually have, he might not be a card with physical, PCI expanders and stuff. He might kind of be built into the motherboard, but he's gonna plug into some USB port here. Your CPU is going to talk USB, or he's going to talk PCI to this guy, and he's going to ask this controller to talk to your controller. Is an overloaded word here. We're going to use gamepad here to talk about this guy. We're going to call this gamepad, so that we can call this USB controller. Okay, that's just going to be clearer, right? So this guy, we talk PCI to him. We ask him to wiggle the wires to talk to the gamepad. This thing might be called, they call it like host controller, XHCI, EHCI, UHCI, OHCI. Those are all like words you might hear for like kind of a standard interface, how you could have a USB controller talk to the CPU, right? Because like there's going to be many implementations of this guy as well. So there's kind of like a standard interface of how the CPU expects to talk to him, as well as a standard interface of how this guy talks to the gamepad, right? The way, so I think that we can kind of gloss over most of these details of how these guys talk to each other, because this will be handled by the Linux kernel for us, right? So kind of on the software side, we kind of have like kernel, and he is going to provide us with a file that we can look at, dev bus USB, who's going to have like dev bus USB, he's going to have like devices, and each of these represents one guy that's like plugged in to here, right? So he's done some things like when we plug the gamepad in, he's got a default USB device address. Someone in like this stack has given him an actual address that he now knows how to use by sending some predefined USB packets over this wire, right? So this wire is essentially, you can think of it as one line. It's actually four. If I remember correctly, I should double check this. I think it's four. One of them's like ground, one of them's voltage, and then the other two are like data plus and data minus, where you're kind of saying like, instead of using one wire that looks like this, you use two wires and you send like the opposite. You kind of like look at the difference between these two, right? So you're going to send like, I guess, another one that's kind of offset from this, or maybe if you want the difference to be 0, you can kind of fix them the same and then move them in opposite directions. You could do it like this way. right? But the idea here is that instead of sending one wire with like high low, you send a pair of wires where the value is determined by like the difference between the voltages on those lines. And my understanding of why you do that is because like high speed buses, they get kind of more sensitive to electrical interference, and if you put these wires next to each other, the interference will affect both wires like kind of the same, so that you don't ever end up like, if you end up with like a line that kind of starts looking like this, that'll be mirrored on the other side as well, and so like the difference between these two wires will stay the same type shit. Anyways, not really important, but on the wire they're going to send some stuff that kind of is framed as like packets. And so some of these packets will, they start with some stuff and they say like, I would like you to set your address to this thing now, and now this guy has an address, right? So when we were looking at the USB specification, they talk about like device states. And so this is kind of like the USB state machine. Like you plug the guy in, he gets some power, he gets his default address, the kernel assigns him a real address, then you configure him in some way. And my expectation at this point in time, which could be wrong, but my expectation as of right now is that we are going to be responsible for configuring, right? So this is kind of hand wavy, our understanding at this point. There's, what else do we know? We know that there's like multiple ways that you can communicate with these guys. There's like bulk transfers, there's isochronous transfers, which are like at a constant time interval, you're going to send me some constant amount of data. Stuff like a microphone, my USB mic. He's going to say, computer, please ask me for this amount of data every this amount of time type shit. There's like interrupt transfers, which are for like my mouse. When I wiggle the mouse around, sometimes it's doing nothing, sometimes it's doing stuff. And so we need to be able to ask the host to poll us every once in a while. We read somewhere that the USB communication is all initiated by the computer. So there's as far as I understand right now, there's no way for the mouse to ask to send the computer some data without the computer asking for it first. So that's kind of overall the understanding. I'm sure that we'll kind of like look more stuff up as we go. But I think we want to start by just, starting to write some code and see where it takes us. Because, it's very cloudy in our head right now. And I think going through the effort of talking to the kernel and asking it for stuff will solidify in our heads the way things work. There's this library, libusb. If you look up like, how do I interact with USB devices, they'll tell you to use libusb. We're not going to do that shit around here, right? We ain't no bitch. We can do whatever we want. And so my thought here is that if we're going to be implementing low-level USB stuff on the device side, getting as low level as we can on the host side within reason is going to make our lives easier. It's going to make us give us more knobs to play with and a better understanding. We don't have to spend time understanding like the libusb abstraction layer. We might regret this decision, but it's fine. So I think we're just going to open the character device, see what it says, and work our way forwards from there. Okay, so there's this program, LSUSB. I don't know where I picked this up. I picked it up somewhere. But if we look for my controller, I do have to plug it in, it turns out. If I want to find it and we want to talk to this guy, we should plug him in to see what he says. So let's try again. Here we go. We have a Gang Zoo Chicken Run Network Technology Company Limited GameSir K1 controller for Xbox. Hype. So he's boss 1, device number 8. So that should be this guy. Theoretically. Rolls off the tongue. Yeah, it really does, doesn't it? So I guess when we read the kernel docs for what these character devices provide, they tell us that when we read this thing, it will give us device descriptors. Or sorry, it will give us the device descriptor. So there's one device. And then the descriptors for current configuration. So we kind of skimmed over some details here. They're in the spec, they said many times, they were very, very clear about this. There is one device descriptor And you can use that to set up these things that they call like logical pipes. So you can kind of say, my device is at this address, but he's going to have like a sub address for each thing that we might want to do with him. And so supposedly, I think that's what we're going to see here. Are all the VODs going to be available here on YouTube? We'll post the coding segment on YouTube. The reading segment, I think, is going to be Patreon / YouTube member / Twitch VOD. So I think the first thing that we want to do is just cat this guy and see what he says to us. Right? If I'm just like, probably we want to hex dump this thing because I think it's binary data. You know, there's some stuff in here. And like, what is it? I don't fucking know, man. So, see the USB 2.0 spec for details about these binary data formats. So here they're saying the first thing should be the 18-byte device descriptor. So first of all, how many bytes do we have here? Way more than 18, right? So this is 8, I think 1, 2, 3, 4, 5, 6, 7, 8. So this is 16, 18. Up until here is the device descriptor. And they're saying you just get that shit raw, right? That's kind of what they're saying. And they're saying check the USB spec for what that thing is. So I think that we saw that everything interesting here is going to be in chapter 9. And can we just start kind of, what is this? This looks like it says descriptor here. Descriptors, yeah. So that's 9.5. So here we have device descriptor, and it's probably this. Does this look like it's 18 bits or bytes? It does, right? So they have standard device descriptor. We have length, descriptor table, BCD representation of the USB spec that it has, the device class, subclass, blah, blah, blah. So I think we start here. And I think I would like to work in Zigland. I think it's just where we're most comfortable recently. So can we do like USB user space test? We'll call it. Let's get an environment that has Zig in it. So we'll just copy paste a shell.nix and see what we got in here. We probably don't need this. Yeah, that's probably fine, right? Probably. Get in it, next shell. Ray March, thanks for the raid. What's up, guys? Shit blob sounds like such a fun project. Okay. We don't have to comment on the fact that we're calling our shit blob. It's just, it is what it is. I should have called it a codename Dingleberry would be so good there, but we're getting off topic. Ray March, thanks for the raid. We just went through intro, so we're not gonna give you guys like the big intro, but for reasons, we're trying to write a user space Linux driver. And what we have so far is that you know, this guy, you cat him, you get some stuff back, we're gonna try to interpret the stuff. That's kind of where we're at right now. Okay, let's do a little edit source main.zig. We gotta get up and running. We go pub function main, he's got an error, we return error hello, and zig run source main, he's gonna say uh-oh or hello, cool, and then I guess we might as well set up a build setup as well. So here we're gonna be like, you know, he takes in a standard builder, import stud, boom, and then we're like, how do you do this? You get like a target, and an optimization level, and then we make an executable out of this guy. So we're like, please make an executable out of, you know, what is it? It's like, use our file source main, use that to write an executable of name USB test or something with target of our target and optimize of our optimize, and then install that shit. Okay. So now we would type zig build. It's so cool that build scripts are in the same language. If only that had that in CPP. Well, I mean, You could always just make one. You could write a build tool in C that you compile and then run. It's almost the same. Okay, cool. So we're up and running. We're up and running. So we probably want like to use the standard library to read a file. Open file absolute, and I guess we probably are going to just hard code for now the device handle. So it was 1.8 because we don't give a fuck. Okay. Then I guess we are going to read the first 18 bytes of this file into our device descriptor. Maybe we have to. I don't really know what's going to happen if we try to like open it, then read two different segments of it. I don't know if it'll like could keep its stream location. It should, right? The kernel will probably have some sort of tracking data structure for this file handle, and that file handle will know that it read 18 bytes previously. So I don't think we have to like read the whole thing at once. I think it's probably fine. So let's say we have like the device descriptor, and he's gonna be 18 bytes of undefined data, and we're gonna just read that shit into the device descriptor. And I guess maybe let's print what we get back first. Like this. He's mad because here we need to do this. I guess we should say like read amount, and then maybe we assert that read amount really was 18. Okay, and then let's do like a little zig build and run it. Okay, so that looks, I think, like what we saw when we did our hex dump. This is in hex, so can we print as like, can we do this? Print as hex? He doesn't like that. Maybe like this. Okay, so does that match? 12.1.2, 12.102, 12.102, 00, 40, 37. Yeah, okay, I think this is the same shit. Seems like this is the same shit. So now the question is does this match what we see here? The standard library knowing all the details to support a platform compiler flags, I suspect, is a big part of why it feels good. Not sure how those spaces are unsafe for CPU. Yeah, that's true. I think you're probably right. Okay, so I guess we want some sort of like USB descriptor here, right? And I guess probably a packed structure here that is backed by, maybe not backed by anything. Here we say we have length as U8. I think that we saw that the multi-byte fields come in big endian form, but the Linux kernel will turn them into host byte order. Right, so here we saw that the binary data consists of the device descriptor. Multi-byte fields in the descriptor are converted to host endianness by the kernel. Right, so we don't have to worry too much about it, I think. I think we can just kind of use it as is, which is kind of cool for us. Descriptor type is U8. And I wonder if it makes sense for us to just start like, can I copy paste this? Like, can we just do some like bullshit? What happens if I do this? Yeah, that's a shit copy paste, huh? Let's not do it that way. Okay. So BCD USB, which was how many bytes? 2. Then we had class, subclass, protocol. Packet size, max packet size. Vendor ID, which is 2 bytes. Product ID was next. BCD device, which was how many bytes? 2. And then it was manufacturer, product, serial number. Product. How could serial number be 1 byte? Index. Oh, because there's string descriptors somewhere that we eventually have to find. Okay, so first of all, we should have maybe an assertion here that that bit size of USB descriptor. So if we look at this thing without padding, this should be 18 bytes or 18 times 8 bits, right? Can I just do this here? Maybe I have to go into function. Not really sure. Okay. So does that compile? It does. Hype. And so now we should be able to cast this shit to a device descriptor. So really, maybe we should start with this as a USB descriptor, like this, and then we probably want to do like as bytes here on this guy, if we'll convert him. He doesn't like this because this guy has to write any here. And I guess we should run this thing. He's mad. So read amount here was not 18. What was it? The fuck? $32. So he's probably just got padding here that we don't want. So yeah, if we just do this, because like this guy by default, I guess as bytes is taking his like size of, which this like includes padding, which is why we did bit size of here, which is fine. Which is fine. We just need to make sure that we don't overread. Okay, so what's he say? We got length 18, so that's a good sign. Is this single byte though? So descriptor type 1, BCD, USB. So this is binary coded decimal. So I guess that we need to look at this in hex to get a better feel. So this is like format this format 512. So this is USB 2.0. That lines up. Which is good. What else do we have in here? We got class. So if this field is 0, each interface within configuration specifies its own class information. Okay, interesting. We have subclass also 0. So probably the same shit. Protocol. What do we have for protocol? We have 0 here as well. So these codes are qualified by the value of B device class and device subclass. And so we're, again, it's per interface here is kind of what they're saying. So it doesn't fucking matter. Max packet size, we saw 64 and it's saying 64 is valid, hype. And then is the vendor and product ID, do these match what we see if we type ls USB, right? So if we do this guy, we see that this guy has 35371086 as the product or the vendor product IDs. So can we just get this to print as hex? Is that allowed? How the fuck do we... I thought that was allowed. Zig format type hex. Format fields. Why is this so big? I thought there was allowed. This was allowed, but I guess fuck it. I'll just do the conversion externally because I'm sure it's possible. I just don't know how. So can we just look up Python 3? So we got format It's like this. Boom. And this other guy. So we got 3537, 1086. That matches what's in LSUSB, right? So we're kind of chilling there. So looking kind of like this stuff is working a little bit as expected. BCD device 101. So what is that? This is device release number. So they're saying that this controller is 1.01. So there's been one revision on this thing. Then in the string tables, we have manufacturer, product, serial number, and no configurations. Cool. So I guess the next thing to do would be like, how is LSUSB getting this stuff out, right? They're saying that there's some string table somewhere. Standard USB, I see string in the table of contents here. So I guess asking the USB device for its string table is kind of the next thing to figure out, which is kind of like a good entry point into like interacting with this device at all, right? Presumably, there's some like memory on the controller somewhere that like holds all of the strings that we want, and we must be able to ask it for those, right? Surely. So it looks like these are descriptors, right? And when we looked at like the hex dump of this guy, right? When we like cat this file and hex dump him, we are not seeing the string table in here, right? So that's interesting. What comes in here? So when we see a string descriptor, they're Unicode, blah, blah, blah. And they look kind of like this, where the string content, is it directly embedded in here? It seems like it kind of would be, right? And so my guess here is that this is not one of the things that is automatically printed when we read this file directly. So I suspect that that means that we would ask for it, right? I think that I saw there's like a get descriptor call somewhere. I don't remember where we would have seen that. USB device requests, probably. Maybe over here. I think we saw like get descriptor is like a thing that I've seen here. Right, so this is a request here where we can say, yo, sir, please give me this shit. Right? We don't really understand how at all that works yet, but surely it's possible, right? So this is all under the header of USB device requests, where we talk to the device's default control pipe and we do like a control transfer. So I guess what we need to figure out is how the fuck do we do a control transfer, right? And then presumably we specify the get descriptor thing in here, probably be request. And then somehow we need to like follow the descriptor flow to get the answer back, right? Surely. Okay, so let's go back to the Linux shit. Which, was it in another browser? Yeah, it was. Okay. So, how the fuck? I assume it's this guy. So, we want to send a... What the fuck was this thing called? A control request, right? So, you know, we've seen from the reading that we did in Happy Hour that there are 4 types of ways to talk to a USB endpoint. There's control, bulk, isochronous, and interrupt types. And this is a control message, right? He's saying we talk to the control pipe. So the control pipe endpoint 0. So we need to figure out how to send control request to the device. Issues a control request to the device. That seems promising. So synchronous IO. We want to send this control message, which I guess is coming through the ioctl interface here. That's my guess. Right? So how the fuck do you do this? So I guess we probably want to look at these headers probably and try to figure out where this is going. So Linux GitHub. Let's look at this guy. And we're looking for control in here? No. Wrong header. Was it the other one? UAPI, of course. We're user space. Okay. Control. Okay, so there's USB control request here, which this guy has all of the fields here that match this table, right? So somehow we must be able to send this message, which probably is coming through maybe from this header, right? There's going to be like some ioctl, definitions, right? So somehow we need to find this guy. The ioctl parameter points to structure like this. Yeah, so where does this guy get defined? I assume that that's in one of those other headers. Can we, maybe we can search for define this. So this is coming from USB device FS. Yeah, so they are defining ioctls on this guy with this parameter. Cool. So we should just be able to call that function with this and with the appropriate struct definitions. I don't know if Zig's standard library has this stuff defined for us, or if we need to go pull those headers in ourselves. I'm not sure. So maybe looking in the standard library might be kind of useful. Can we look for what are the chances, right? They seem pretty low. Loading. Give them a sec. Do you have a Solana address? Nope. Okay, yeah, so nothing in here if I search USB that looks too promising there. So I assume that we pull these headers in ourselves, right? Surely. So we go UAPI is import C import here. And we're Linux USB.h. Not found. He's a lying piece of shit though, actually. Or maybe I have to try to use it first. So we call how do we issue ioctls here? Surely something like this, right? So we go on this file, could I send you API dot whatever this fucking thing was called, this with null. This thing needs this guy returns a file, but this guy is going to have a handle. So we should be able to do this. Okay, and then does that compile? No, because he's libc headers are not available because we don't link against libc. So I think if we just go in here and we go exe link libc, he should be fine. Unless he thinks that that's completely unrelated. I'm not really sure. Okay, so now he's just saying it can't be found, so that's not really helpful. So maybe that's not related. Maybe. Do I need to specifically add these include paths? If I try to, okay, can we just do a quick C test here where we try to include Linux, what was it? usb.h, and then int main void, and can we like print the ioctl here? Like, does this work? If it does, then we might have to do a little bit of finagling to get everything to work with Zig correctly. Um. Was curious if you're a software engineer outside streaming, or do you do streaming full time? Streaming full time for the time being, but I have worked as a software engineer for non-zero amount of time. Okay, so this is a good clue that this is not right, because this doesn't work with GCC either. So where the fuck is this UAPI? Can we look at like Linux kernel headers? Maybe we need to like add these somewhere. Headers. Or like, can we look for like a UAPI Linux example? Like, is there? I just want like a example of anyone doing anything with the kernel. Do I have kernel headers installed? Yeah, maybe not. It's very possible. I just want to know, like, are they supposed to be in like user include Linux type shit? I mean, we could just add like, maybe we do just need to add Linux kernel to our list of things that we want in our shell. It's very possible. Oopsies. Work USB is just okay. So if we're like just like Linux, is Linux packages the one? Linux OS package search. Bum bum bum. Like, what do I have? Like, because I do have like I clearly have a kernel installed, but I just don't know if that's different than like. Can we just do this or something? I don't fucking know, man. I don't know. Not a valid type. So I'm supposed to do like oh, I see. So there's kernel packages which are going to have kind of more stuff inside them. Is it just Linux? Could be NixOS Linux headers. Yeah, this sounds like me. I'm like, how the fuck do you get the headers on this fucking shit? Fine. Nix locate. I mean, can you just tell me the answer? Kernel headers. Here we go. So who the fuck? Where does this guy get included as? God damn it, dude. Why is everything so hard? Kernel, what is it? Kernel dash headers? It's Linux, Linux headers? This doesn't have like a, this doesn't get like a name. But I assume it's Linux headers. It's gotta be it, right? It's gotta be it. No, he doesn't like that. Attribute Linux headers. Maybe it's just like just I slap Linux headers here. That looks promising. There we go. And then still though, no dice. Grep Linux headers. We do have this. Include Linux USB. Ooh. USB.h doesn't exist. But there is USB device FS. Oopsies. Which I think is also where we saw some of these things defined. Okay. Expected expression before struct. True, because this is just... cool. I think we're getting closer. Okay. So if we go back into main.zig here, and we're like USB device fs.h, he's chilling now. Hype. And then hopefully we can like jump to definition on this guy. Nice. Nice. Okay. We're looking... This is getting us closer. Okay. So USB device fs control. Here. Okay. Which he doesn't like for some reason. Oh, he can't fucking convert the... He can't convert the ioctal numbers. That's annoying. But we could print them from here. I thought this is supposed to be an ioctal number. So I thought that you could just print them here. But maybe I'm stupid. Have you ever written arenas in C? No, but we did do like a whole memory allocator adventure in Zigland where I'm assuming it would end up in a very similar place. So we did the whole like mmap stuff from the kernel, write an arena, make sure that the allocator is like aligned correctly and all that shit. Yeah, I thought that this macro creates a... I thought that it creates a ioctal number. That's what I thought. But when I try to print it this way, he's getting angry. Which is just kind of confusing. Can we run like the preprocessor here? Does this not like fully expand? Yeah. Oh, you see these guys? I could have sworn that these define numbers. Which makes me confused about why this is not working. Let's get proper Clang tooling here so that I can jump to definition. Can you explain the origin of your Twitch username? Is it a reference to something? It's just like one time I hit the random, what's it called? Random article button on Wikipedia. Include ioctal.h? Oh yeah, that seems pretty lucky, huh? If it's like just not defined correctly. Yeah, nice. Good eye. Good eye. Yeah, there we go. That's a fucking number, dude. So here, now we can run this shit. We get the value out now. And now, since Zig is having trouble parsing these, we can just, you know, spit it out here and then copy paste it in. Which is going to be our workaround for now. Okay. So now he probably wants us to pass in... Is there a better ioctal function in here? Stood CI octal, which is, oh yeah, stood, it's fine. Stood OS Linux octal IO read write. Maybe if it works if you include octal and zig as well. Oh yeah, I guess maybe, huh? I just kind of assumed it was a zig falling over thing, but you're right, it might not have been. Might not have been. So it was like a USB devfs control, which he's like unable to translate macro undefined identifier. Oh, which means that we should be able to get that identifier, right? He's like, maybe it's fine. Oh yeah, it is fine now. You're right. So if we just write the 0 here, does this compile? Yeah, it is. Nice. Nice. Good eye. Good eye. Okay, cool. Then we're chilling. Okay, so we need to, when we send this control request, we need to fill in the fields of this control transfer, right? So the octal parameter points to a structure like this, right? So we should be able to say like control request is gonna be like USB dev fs control transfer. And here we need to like start slapping everything that we want in here. So I think we have to do it kind of like this. And then this is gonna return the error number. I could have sworn there's like a nicer version of this that converts things to errors and stuff, but doesn't really say like this, but it's fine. It's fine. So we get some return value from this guy, and I guess we will look at the return value eventually. And then I guess all of this is supposed to come after we read the device descriptor. You know, hand wavy. Okay, so what goes in this shit? This is literally just the stuff from the spec. So here we want to create one of these guys. Okay. So we're gonna be like request type, I guess, which is a U8 that has the lowest bits are gonna be recipient, right? And then we have type, which is 2 bits. This is actually U5. I think this is inclusive because 2 to the 5 is 32, so that lines up here. Then we have 2 bits for this guy and then 1 bit for direction. Okay. Then in reality, if we wanted to get fancy with it, we could go like, you know, direction is an enum U1 that's like host to device or device to host, and then we can put this here. Wow, fancy. Right, we can do the same thing with type, which is backed by U2. And then we just have these options. So standard, class, vendor, and reserved. Device to host 1. Yeah, true. True. And then recipient. And this is a non-exhaustive enum that has device interface endpoint other. Other, this is equals 0, 1, 2, 3. Cool. So that handles that. Then we need the request, which I guess is gonna come from this guy, right? Or what was it? It was get string table or something. Get, it's probably get descriptor, right? So here we're gonna say request type. He's saying that he only wants the top bit set, which means it's device to host standard device, right? That makes sense. So here we have B request type is recipient is equal to device, type is equal to standard, and direction is host to device, or is it device to host? Device to host, because this thing has a 1 leading bit. And then this is actually going to be a B request type here. I guess we do int bitcast, right? And we start this with a request type here. I think that works out. Recipient here, we didn't write recipient like this. But now that kind of covers first bit. You misspelt it. Oh well. Okay. Get descriptor now. So where does this come in? Get descriptor is 6. So here we probably want to do like device requests here. And this is B request is a U8, right? If I remember correctly. And here we'll just do, non-exhaustive enum because we're fucking lazy, but we'll copy get descriptor here, right? So it should be like get descriptor is equal to 6. And so then we should be able to say that, our request, which starts with a B for some fucking reason, is, he comes from device request get descriptor, right? That seems kind of reasonable. Seems kind of reasonable to me. Okay, and so now our W value. So we're going to set windex to 0. He's saying because it can't be 0. Length is descriptor length, which we probably need to get from the string descriptor down here. Or is this like the response? I guess data is a pointer to the output of this thing? Right? Would be my guess, looking at what the fuck is in here. Right, so this is data. This has got to be the output, right? Otherwise, we would never get the data back. The B stands for USB. I think it's byte. I think they're doing what's it called, Hungarian notation, where they just put the types in the names because like your ID couldn't figure out before. Hungarian notation. Oh no, Hungarian notation says B is Boolean. So this is probably USB spec specific. B for byte, W for word. I think you're right that makes sense. Right, so these are probably telling us W means 16-bit, B means 8-bit type shit. Okay, so I'm going to assume right now that if we do B request is U8, this is also U8. Why does he can't do bitcast? He should be able to bitcast that. I'm confused why he can't. We'll come back to that. Maybe it's just like this, actually. No? Int from enum, maybe? Yeah, there we go. Better. Okay. Yeah, I'm gonna... Well, we could read this. The first 8 bytes, blah, blah, blah. If WB length is non-zero, it describes the length of the data buffer, which is either written to the device or read from the device if it's input. Hype. Hype, hype, hype. Okay, so we need our... I guess if we're trying to read the string table, we add a buffer that conforms to this guy, which we can't know the size of this thing until we read it once, right? So The Unicode string descriptor is not an alternative. The string length is computed by subtracting 2 from the value of the first byte of the descriptor. Okay, let's... So, I guess we could just allocate a bunch of fucking space? So, Unicode descriptor... What am I looking at here, right? This all seems reasonable to me, right? This guy comes back and he says, yo, I'm this long, and here we go, and then here are a bunch of like 16-bit numbers specifying like something, right? But then like where does this come in, right? So the Unicode string descriptor shown in table 916 here is not an alternative. The string length is computed by subtracting 2 from the value of the first byte of the descriptor. Right, so here, maybe we call get descriptor with the index of the string. Right, so this tells me how many strings there are, and then maybe this tells me what they are. Right, so maybe there's an actual like Unicode descriptor request. Right, that would kind of make sense. So there's a device descriptor. Yeah, I'm missing a piece. What if the descriptor type comes in as Unicode and you can look at the second table? Yeah, that sounds kind of right to me, but then like how do we get that table? You know, because I don't see a standard device. I guess get descriptor, we need the descriptor type and index here in W value, which we haven't figured out yet. So surely W value must somehow be core, like this must be populated probably with some, like we say Unicode and or in the index of the string we're looking at, right? So when we printed this shit before, we ended up with like some string table ID that had like the manufacturer name in them, like ID 0 or ID 1 or something. And so we must, somewhere we have descriptor types probably defined. That makes sense to me. So where do we get those? Surely we just look for like get descriptor in all caps here and just look for the rest of this. Okay. So we did see language ID stuff in the string descriptor table. Where do they talk about value here? So this specifies the descriptor type in the high byte, refer to table 595, okay, and the index in the low byte. So that's here. So none of these say Unicode? Oh, but 915 just says string descriptor 0. So string descriptor 0 is special. All of them are 1 indexed. And then if we ask for string 1, we get this back. That's my bet. Okay. So we want to use the string. I think we want to use string. Wherever the fuck that was like 9.5, right? Table 9.5. Oops, fuck. Which was like down here somewhere. Yes. I think we're getting somewhere. So here we want like descriptor type. And this is, I think, a U8. And here we want string is equal to 3. right? So that's what it says here. Then how do we get the index in there again? Get descriptor. So we take the fields in the high byte and the descriptor index in the low byte. Gotcha. So here we're like, this should be int from enum of descriptor type string, shifted left by 8. This needs to be as a u16 for this to work. And then we or in 1 to get us the first string. I've been watching you for a few months now. Are you preparing your own OS, Sphere OS? We've actually done that before. This was one of the first projects on the stream 2 years ago. But we got pretty far. We got to where we could play Doom, I think, using mouse and keyboard on it. So it's been done. It's been done. What are we missing anything here? I guess probably, right? Where is like the descriptor? This is what we're doing, right? So on get descriptor, they let us zero out some more things. So we have W value done, 0 or language ID. So I guess 0 for Windex is hype. Then length is how much room we have for the output. So we'll just say like, you can go fucking crazy here. Like we'll give them 128 bytes, and then we give them a pointer to the data. So you know, string buff, we'll call it. And then here, I guess we should use string buff len. And then here we should define string buff as, 128 U8s. Here we need to int cast this probably, and then here we probably need to provide an address. And then can we just, print the string buff? That'd be kind of hype. Okay, so he gave us some big-ass number for return, which makes me think that it failed. And then the string buffer is, we're at the very least, garbo. I wonder if we could do, like, fill it with the character A first, then we can see if it's written or not. How do we do... Can I not... Oh, is it like this? You have to be a string? And then, do I dereference this guy or something? Is it like this? Yeah, there we go. Okay, cool. So it looks like this thing failed, and we got, our buffer was not modified. Right? So that makes sense to some extent. It would be nice to see what the error code is. So can we maybe look at this as an i64 and bitcast it? Because I think that's what the return type of this shit does, if I remember correctly. So he got -1. And then I guess we're probably supposed to look at Erno here to see what the actual failure was. So yeah, it sets Erno here. So do we have Erno in Zig land? We must, surely. So this takes in the thing, but how do we get no out? Oh no, because surely like Erno is like a libc type thing, right? So this is probably like surely the syscall returns. It must. The syscall has to return, right? If we look at like what this thing is doing, he's just calling this. So can we look for maybe users of this thing? I mean, it could just be that the return here is -1 in general. There's so much that could be going wrong here. Hold on. I'm just gonna SSH into my other account so I can look at well, can I look at dmessage? No, operation not committed. So let me let me SSH into my other account. Just real quick. And dmessage, sudo dmessage, type my password again. So does he tell us anything interesting here? No, right? Dmessage is not yelling at us, but maybe if I set like the log level. Like -n here. I think it's big number is lower level. Sorry, I'm just trying to make sure I'm not like leaking anything important here. Okay, so I set the level, I think. Still don't really see anything interesting. Can I octal with normal user? Yeah, that seems pretty unlikely, right? Although I would have liked to see like an error message that was like, yo, you have no permissions. I mean, these things are read write. Oh yeah, it is only writable for root. So can we do like cho or chmod, 666 dev bus USB 1, what is it, 8? Yeah. Cool. So that now we're closer. He still doesn't like that. I mean, another option here too is that like this USB device is owned by a driver, right? So if we look at like, sys bus USB drivers xpad here, he's like, this guy's owned by that, right? So I think that if we do like echo this device ID into unbind here, now he's not there and we might have a little bit more luck. Still no. I would love to get a better answer out of this. So it could be that I think -1 is just the like generic like fuck you, right? I'm pretty sure. So, oh, what the fuck? That can't be right. Return. Oh, so this is if used libc. Otherwise, enum from int here, which e is from system e, which comes from Linux, and he is just probably like, -1's just not an option on here. I think. Or he's looking at 1, which would be e permission. So fuck whatever the fuck we just did here. E perm being 1, that lines up in some way, right? So can we do... So how is LSUSB working then? LSUSB is getting this information somehow, right? So what's going on there? Which LSUSB? Is he like one of those like bullshit guys that has the ability to do stuff that he shouldn't normally be able to do? He doesn't have any like he doesn't have the like super user shit going on that like automatically turns him into the owner of the file, which would be root. Like there are some, I think if you look at ping, it does that, right? Maybe not. I'm used to there's some like trick there. Maybe we should read a little bit closer. Like permission stuff here. Because I think we saw something about that. SUID, yeah, that sounds right. Yeah, so you saw here. The octals. Fuck. USBFS made. Okay. So no. So these guys are only readable by root. Only root can write such user mode drivers. You can selectively grant read-write permissions to other users by using chmod, such as 666. Right. So that should be fine. Now that we've given full access to this guy. Modified at 1419. So if we do this again, he's not getting his mod time updated, which is bad. Okay. Sudo/doas. I just don't have like root permissions on this account, kind of intentionally, but I guess maybe we could try temporarily, like be like, we can copy it to my other account. I'm down to just do that today. Zig out bin USB test. Here. This should be streamer at localhost, like this, and then just so I don't leak my password, sudo USB test. Yeah, so this is no good either, right? So that's a sign that it's something else. I would love to, maybe recompile this without this shit. As i64 bitcast. Okay. Fuck. Maybe I should just add root to this account. BRB extracting password from posture movement. Yeah. Yeah, okay. So even with root, he does not like that. So it's really hard to know why. Return. Otherwise, standard USB error code is returned. Submission failed because herb reject was set. That seems possible. So what is that? Are we not supposed to like specify, maybe Windex is wrong here? We could try getting a different descriptor, right? Maybe stop with the string table shit and try something else. Or even we could call like get configuration, right? Maybe this is a better thing to try at first. Fizzbuzz, thanks for the raid. What's up, guys? What is up? So we could try this. We could try get configuration is 8. Then here we call, get configuration. Okay, let's comment out what we had before. And then maybe copy paste it. Let's just kind of see. Okay, so this is no longer a control request. This is a configuration request, right? He's like, we're going to do a control transfer. We're going to go device to host. All of this is the same, I think. But now we want to call get configuration. And when we call get configuration, 001 configuration value. Okay. So 0, 0, 1 configuration value. And so then we're like configuration request, boom. And can we see how this goes now? So now we should get 1 byte back. And we see it as a number. So this also he does not like, right? He also doesn't like this. This guy's still returning 0 or -1. which could be because that like it's rejecting the request, or because Linux is e-perming us. We don't really know still if it's a Linux problem or someone else. So it could also be like maybe our open file flags need to right? That seems kind of suspect. That's better. Okay, so we just weren't reading this. Just weren't opening as writable. That's kind of funny. So let's try this again with the string table. And let's go back to control request. And let's see if this guy looks a bit better. Okay, that's promising. So can we write this as a string now? Let's go! Let's fucking go! That's Guangzhou Chicken Run Network Technology Company Limited, baby! Woo, 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 woo! Okay, shut the fuck up. I gotta shut the fuck up sometimes. But that's really good. Well, because we didn't look at the length, right? So they said that they come back with this format, and we just ignored these, right? So this should really be, it should be from like 2 to string buff 0. Yeah, I think it should be like this. Yeah, right there. That's better. You happy? You fucking happy, bitch? Okay, sorry, that was a little rude. Just calm the fuck down. Okay, so that's the manufacturer, and then we could do product and serial number as well, right? So to get product and serial number, we just swap out like one. This should be the product name if we put a 2 there, controller for Xbox, and the serial number is this, which, that could be a serial number. Cool. So that means we've done, our first data transfer, which is pretty hype. And so the question now becomes, what do we do next? Right? I think the natural next thing to do is try to communicate with this thing. So maybe like list endpoints, right? Like we think that this thing has an address, right? We looked at the state machine, I think maybe here, and we think that we're in address state. It would be kind of nice to prove if we're in address state. So how do we like, ask some information about this guy? Like somewhere we must, list we might want to like iterate his endpoints. Maybe we might want to see if he's configured. So what's like set configuration? That's a thing. That's a set of words that I've seen before, right? Oh, when we called get configuration, and get configuration just returned a number. Oh, so when we called get configuration, it returned 1. That was a thing we saw. And so theoretically, we should be able to ask him probably like what the configurations are, right? So probably there's a list of possible configurations somewhere. And we should probably be able to ask him for what that configuration is. Right? So, right? Like this is a configuration descriptor, which tells us, how many interfaces we have. That sounds hype. Right? Probably we ask for the configuration, then we ask for the interfaces, then we ask for the endpoints. Probably. What is the name of the scheme? How they lay out their data? Binary format? Just guessing. Oh, I don't know if it even has a name. So you are running a USB host? Yeah, I guess we're using like the Linux kernel API, so I don't really know like at what level we would consider ourselves. We are trying to interface with a USB device as a USB host from Linux at a low level. I think that that's probably the most reasonable description of what we're doing. Okay, yeah, so I think it seems likely to me that we should be iterating we should look at the configuration, right? So I think our workflow should be get configuration, get interfaces, get endpoints, connect to endpoint? Surely. 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 So let's go back here, and then maybe we'll just call this, like, instead of calling this string buff, we can call this like IO buff. Okay. So our configuration request is gonna be like this. Okay. So this tells us what the configuration is. So I guess we do something that's like you could do like an abstraction here where this guy has like functions on him, right? Get configuration that returns, you know, a U8 here or something. That seems reasonable. And then he does this part, right? Boom. Boom. Yeah. And then this returns like, you know, an error potentially. And then here, this takes in self as a USB. And then I guess here we know that our like, you know, ret is a U8. And then this guy gets ret like this. This is like, I guess, the configuration index, I guess we can call it. If we're gonna call this, and then maybe we call this RC. I guess ioctl probably gets split out into like something like this, right? That has like, maybe this is like do control that takes in a, you know, self and a transfer is a, you know, this thing that we've been making. Okay, yeah, that seems reasonable. And he just calls like this with transfer like this. And then if ret is less than 0, we have like a fucking problem, except ret here is a U size, so can we do like turn him into an I64 like this? Okay, then if ret is less than 0, then we return error. Uh-oh. Okay, otherwise we're good. Nice. Okay, so now here we go like do control with our configuration request. Yeah. And then we return configuration index. Okay, cool. So now we're starting to get somewhere a little bit interesting, right? We're getting like in a little bit of an abstraction. So we can go like var USB is a USB with f is f. And then down here, instead of doing whatever the fuck we were doing, we're just like configuration index is USB get configuration, right? Boom. And then we should be able to be like, we should be able to use that to get the configuration itself. So first of all, this should still compile. Good. And he doesn't, you know, he doesn't crash or anything, which is pretty sick. Then here we now say like, I guess this should be called like, I guess get configuration feels like an overloaded name now. So maybe we want like get configuration descriptor here. Right? And he returns like some complex data type that we don't understand yet. And he's going to do something very similar here, but he's going to, you know, turn this into get descriptor. Okay, that makes sense. And he ORs in the index here, like we said before. This is still going to be device to host. Now, no, the value goes here. So this needs the descriptor type, and this needs to be configuration ORed with index, and then this needs to be like int from enum, and then as a u16, I think. Okay, and then we need descriptor type configuration, which, you know, is going to be defined around here somewhere. Here. So where was string? String was here, so configuration is 2. So here, like, give me a configuration thing with get descriptor, index here, Windex, I think it said 0 was an option here. When we call get descriptor, Windex is 0, and then we get the output. So here, the output is going to depend on like the type of the configuration descriptor. Yes. Yes. So we look at configuration descriptor here, who looks like he is a 8-byte value. 8-bit? 8-byte value. So this is 8 U8s. And then we return ret here. And I guess we'll just call this rec instead of configuration request, make our lives easier. Okay, so we pass the data in here, and then we call like self do control with this request. And then we return the return. So this is going to be 8 U8s. And then we should be able to be like, okay, my descriptor is, you know, USB get configuration descriptor given this configuration index, and then we have information about it, right? Surely. Surely. This is like Minecraft. This is like Minecraft. Your brain is cooked. But yes. We are digging. Digging and digging and digging. So he doesn't like that. So we need to double check these. I assume that this is coming from get configuration descriptor. Yeah, so he doesn't like this at all. He doesn't like it at all. So what do we do wrong? Where was the list of... Here, so get configuration. Well, value is descriptor, type, and index. And so I guess he just doesn't like it, but we don't know why. Okay, let's rewrite this function really quick for get string descriptor to make sure that we did this right. So here, can we just return this, change this to string, and make sure that if we call like get string descriptor here with index 1, like we are back, things should go back to working. We should be able to see like that Guangzhou whatever, which he doesn't like, which is interesting. So it means that we probably fucked up this thing. Index is U8, which I think is fine. I think that should be fine, because I think it should be upcast to a U16 here. I think it means that we fucked this up a little bit. Can we print Brett? -32. Interesting. Which is success. Fuck. Shifted left by 8. Oh, good eye. Yeah, it's this, right? There we go. Yeah, you're right. Good call. Good call. Good call. Good call. Right, it's the high. We need to shift the descriptor type. Good eye. Good eye. Good eye. Okay, so this would be get configuration descriptor like this, and here we're like configuration index, and now this should succeed. Yep, okay. And now we have this thing coming through. So we can look at the configuration thing. He's got his, length here, 9. Oh, this is device qualifier, sorry. So this thing should have length of 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, maybe this should be, it should be 9 actually. I'm a dumbass because, 0 indexed. 8 should be 9 here. Okay, so this guy wants to return 9 U8. Boom. Okay, there we go. Then we have descriptor type, which should be configuration descriptor type, which is 2, right? Because we asked for configuration type is 2. Yes. Hype. Total length of data returned for this configuration includes the combined length of all descriptors. Oh, interesting. So this number might be big. 48, right? So I wonder if this means that if we punched in, is this hex 48? No, this is decimal 48. So if we were like 48 here, do we just get more data? Yes. Oh, so I bet what we're seeing here is he's telling us how many interfaces there are here. So we're like, we are 48 bytes long. We have 0 interfaces. What the fuck? But then, like, I assume that it's trailing shit, right? Because he's saying that he's got combined length of all descriptors, configuration, interface, endpoint, class, or vendor specific return for this, right? Which I assume means that, like, the first thing that comes out here after this stuff would be an interface, right? I assume that's what we're seeing here somewhere, somehow. So this is probably like 9 bytes interface descriptor. You parse out the first these 9 bytes 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you get like something else here, 16 bytes of something else. Len is 2 bytes. Is it? Oh, it is. Total length here is 2 bytes, which is fine. It actually doesn't make a big difference here. But could I? You probably also want to like HID specific stuff, right? So this class stuff does matter. But I would assume that all of that comes under interfaces, but maybe not. What else comes in here? So index of string descriptor describing this configuration. We got some attributes here, like what he supports and max power, right? So the fact that, oh, you're saying that len is 2 bytes because num interfaces here is 1. Right. That's what you're saying, which makes a lot of sense. So let's parse this just correctly. That would make our lives easier. So I bet what you're supposed to do, I assume you're supposed to read once to get configuration, then read again with big length to parse everything. Right? That's kind of my assumption here. So and then once you get like everything out, you can probably like iterate interfaces, and then when you're iterating interfaces, you're probably going to start seeing something more interesting. Right? Because after interfaces, you probably have like the next piece of the puzzle hacked directly after, right? So I would love to see a little bit more about like the, expected order of these things. Each configuration has 1 or more interfaces, and each interface has 0 or more endpoints. An endpoint is not shared among interfaces with a single configuration, blah, blah, blah. So I assume that it's like, my guess, if I had to guess, which I don't, but I will anyways, I would assume that you have like data coming in here. You get like configuration descriptor, interface descriptor, then the interface is going to have like 3 endpoints or something, and then you get like the next interface descriptor. That's what I would assume here. I could be wrong. But fuck it. All right. So I guess I mean, the other option here is that we have calls to directly ask for interfaces too. So you could also just chatter with the device a little bit more and get more information out of him that way. Um, but like whatever, right? Like, so this is like doing it this way to like read with this like total length value that you get out is just a optimization, I assume, so that you don't like take up the bus with a bunch of extra communication. So I guess let's try that. So let's make a proper, you know, configuration descriptor. He's a packed structure, right? He's got, length. He's got type, which is a descriptor type. We already have that guy. Cool. We have total length, 16 bits. We've got num interfaces. Boom. Configuration value. Configuration. I don't know what the difference between these are, but it's fine. Index of the string. Oh, I see. Configuration string index, I guess. I guess we'll call this like name or something. And then attributes max power. And then we expect this guy to be backed by a. We're not going to back it with an integer. That's too hard. Okay. So now this thing, we can call this a configuration descriptor. Boom. And then this is probably something like this. Cool. Cool. And then our get configuration descriptor now will have names. Nice. Okay. Let's just do it the stupid way. So we'll say fix me convert to iterator over big configuration descriptor data. But for now, I'm fine with just being like get interface descriptor, which surely just turns this into interface. Interface is surely another number in here, which I assume based off of the response that we got here from the big guy is 4, right? I'm going to assume that, but we should double check. Interface 4, so that lines up, which is pretty hype. My favorite part of the HID spec is how they try to predict always humans can interface with the computer. Yeah, that's pretty crazy. I also like the sentence, my favorite part of the HID spec. It's funny to exist as a human and have a favorite part of an HID specification. It's just kind of funny. It's like go outside, you know? Okay, so now this guy's like basically the same, but everywhere we said configuration descriptor, he needs interface descriptor. And then that means that, interface descriptor has to exist. Interface descriptor. Reading specs like poems. Yeah, we're getting out here. So this is here. So we got length. We got descriptor type, but this should be interface descriptor type. And this should be renamed to. That's fine. Let's just put a U8 here for now. I don't really want to get crazy. Interface number. Alternate setting. We got num endpoints. We got interface class. We got interface subclass. We got protocol. we got interface. Interface name, we'll call it. All right, that's some stuff. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that lines up. This says 8, but it should say 9 because, 0. It's fine. That's 9 things. So now, why doesn't it like that? Because I spelled interface wrong, probably. All right, pipe. And then we should be able to just be like, interface dest is try USB get interface descriptor with this ID, and then we should be able to put that shit. Oops. Interface description. Boom. All right. We fucked everything up because, this guy was guaranteed to be a U8, but the zig for loop turned him into a U size. We gotta turn him back. He doesn't like this, which is interesting. Quite interesting. I thought for sure we had that shit. So maybe... I wonder which part of this is wrong. I wonder if get interface or get descriptor with interface doesn't have to be implemented because they return it as part of the control, as the part of like the big boy, as part of the configuration descriptor. That's a possibility. Because everything else in here seems right. It's like exactly the same as configuration descriptor with interface descriptor 4. I wonder if Windex here. No, because that was allowed to be 0 for the get descriptor call. Yeah, I'm surprised. Okay, we'll just do it the other way. That's fine. So we can just call this get full configuration descriptor, where this guy's going to take in, the total length. Which I think was a U16, right? And I guess this is like, we'll return some fancy fucking type here. So this is like a runtime parameter, right? Which means that maybe this is like more like the output buffer. I think. Yeah. So we're gonna be like, write this shit into output buff len, and we're gonna put it into output buff pointer. Okay. Cool. So you went from game to engine to gamepad to making your own gamepad rabbit hole? Yeah, something like that. That's some classic us shit, dude. And then I guess we're gonna return like full configuration descriptor initialized with the output buff. Assuming that this went okay, right? And then we just need to implement full configuration descriptor. So we're like, we guess we have like buffer here, right? And I guess we are going to have, he's gonna like iterate over stuff, right? He's got like a bunch of fields in him back to back. And, he's gonna have, I guess, many types here, right? His first piece is going to be the configuration descriptor himself. Which is a configuration descriptor. Then he's got like interface, which is an interface descriptor. Right? And here's gonna be like, I'm gonna output one of those things. That seems reasonable. The act of programming is a depth-first search process with endless tangents. Exactly, yeah. We just DFS all knowledge. Okay, so I guess he's gonna have like an index in here of like where he's looked at, I guess. And, we like assign this thing and, I guess we like parse this thing. We know that the first field is the length, right? And then we have the type here as this guy. Yes. Okay. Then we probably, increment index by the length that we got here. Uh-huh. And then we parse the type. So if it's we probably cast this into a descriptor type. Which means that like this guy needs to be a non-exhaustive enum because otherwise he's gonna like freak the fuck out, right? And then if we're like, if we get like configuration and we return, return configuration is equal to, probably like bytes to value of the buffer from index onto the index plus bit size of full configuration descriptor over 8 or something. I think that's right. And then if we see this guy as interface, we just do the same shit. Right? Just with interface descriptor. That sounds kind of right. And then anything else, we just like keep looping. Yes. Okay, so that means that like this whole thing has to end up in a loop. Right? Because like if we have something that we don't understand, we just like we'll skip it, right? And then then I don't fucking know. But I guess we will see. I guess also we need like our exit conditions. So if self index is greater than or equal to, this, then we return null. Yeah. Yeah. So now he's mad because 176, he's like, index doesn't exist. True. So now we're like, okay, we get the descriptor. Full descriptor is get configuration descriptor with configuration index and descriptor total length pipe. Then we go like while full descriptor next, we get some like, field, some descriptor, and we can print that shit. Is this C++? No. It is Zig. Similar like level, different desires, I guess. Oh right, we want a buffer here. So can we just say this is like 4096 U8s? And then we use output buff from 0 to descriptor total length here. Yes. All right. What's he mad about now? Packed structs cannot because full. This is not a packed struct. True. True. Unused local variable. Am I fucking high? I just fucking wrote that shit. I wrote output buff 0 onwards. Did I not? Did I not? Well, bitch. Listen the fuck up. And then when we call this guy, this shit needs to be int cast. True. And then he has no function named init. True. Okay, all of this is starting to look okay. 32. Nope, we're at 97. Else, not underscore. I'm a dumbass. Okay, bytes to value wants the name of the type in here. And then probably here we can just do like, we don't need to specify the end. I think that it figures that out for us. I think we can just say, go as far as you can. Cool. So this is promising, right? We first read a configuration descriptor Then we read a interface descriptor, and this interface descriptor has interface num0, alternate setting 0, num endpoints 2, interface class 255, interface subclass 93. This looks like, something sane. Num endpoints 2 seems maybe reasonable. So I guess now, can we, when we're like iterating shit, can we log the things that we don't understand? Right? We can just like print unknown interface type, and then we'll just slap the number in here, I guess. That sounds reasonable. So here we want, I guess, tip. And here we get 33, 5, and 5. So 33 seems invalid. So my guess here would be that we're supposed to parse endpoints directly after. It still says length here. So we like anything. Oh, this is interface here. I got, I got tricked. Where is my endpoint shit here? So B descriptor type, maybe this should be an endpoint descriptor type here. Maybe directly after interfaces, right? When we guessed configuration, interface, endpoint, maybe that's what we're supposed to be seeing here. Maybe. It would be interesting to see endpoint descriptor types. Oh. Which 33 would not match up, right? 33 seems weird. Can we print the configuration as like raw bytes here? I just wanna look again. Okay. So 9 bytes here, 9 bytes here, 2, 3, 4, 5, 6, 7, 8, 9. Then we get 16 bytes here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 7 bytes here, 7 bytes here. So that does look like it parses correctly. I just don't know what this 33 is. That's interesting. So I guess that means that there are probably some descriptor types that maybe it's just not defined here, right? Maybe that's an extension by some other part of the protocol, right? Because if the other guys have endpoint 5 here, which they do, 5 here and 5 here, then that means that like this is something associated with an interface. Probably if we look at like gamepad spec or HID spec or something, we'll see what that one is. So we'll skip that for now, but we will look for endpoints. I think that's the next step here. So we have configuration, we have interface, next up, endpoint. So here we're like endpoint, and here we're just doing the same shit. We're like return endpoint with endpoint descriptor, and then we need to define what an endpoint descriptor is. Okay. So that's this thing. So we got length. We got descriptor type. We got endpoint address. We got attributes. We got max packet size. We got interval. We got, that's it. So this should be 7 bytes. 1, 2, 3, 4, 5, 6, 7. Nice. And then in our iterator here, we just need to make sure that we know how to output that guy. So endpoint is an endpoint descriptor. All right, cool. So now we have endpoint descriptors here with address 130, max packet size 32, interval 1, and then endpoint 2, attributes max packet size 32, interval 8. Cool. Cool. Word association, I hear length, I think girth. That's crazy. that's not good word association. You got to break that one up. So it said earlier that host byte order is handled by the Linux kernel, but I guess that would we should double check that that's true here, right? Because we don't really know if that's parsing all fields. Like if he's correctly recursed this configuration descriptor, that's hard to know, especially in the cases where he doesn't know about the device type here. But maybe, who knows? Who knows? Max packet size is 2 bytes and he's saying 32, which I think is pretty fucking reasonable, right? Because otherwise, if it was in the wrong endianness, we'd be seeing like some big ass fucking number. 32 is reasonable, so I think this is correct. Okay. Cool. So that brings us to 4:05, which is about when we try to end. We have successfully interacted with this USB device a little bit. We have not actually transmitted any useful data yet, but I think that we have made a lot of reasonably good progress here, right? We've managed to, from userspace on Linux, open up a device handle and start chatting with this guy, right? So we've managed to ask him what his name is, who he's by, like what serial number does he have, as well as like how we've got through like the first couple stages of how do I talk to you, right? We know that he's using this configuration. This configuration has a couple endpoints on one interface. We don't know what this guy is yet. This descriptor 33. I'm sure that this is like pretty important. And so I think we call it here for today. I guess next stream will be about actually trying to extract the correct data from this guy. Oh, this is kind of interesting. I don't know if you guys see this. This light is usually not on, but probably because of the fact that we have disabled the XPad driver, he doesn't know how to turn it off anymore. So that's kind of interesting and fun. But anyways, yeah, I think next stream we try to get some interesting information out of it. But that's for tomorrow. So thanks for watching, guys. If you like what you saw, we stream most days around 12:30 Pacific time to 4 o'clock Pacific time. It is 4:10 now. So if you're watching live, anywhere between 3.5 hours ago to now is when you should expect to see us. We're working right now on this make an Xbox controller shit, which we will probably stay on for a little bit. I think there's a lot to do here and a lot of fun to have. But if you want to see other stuff, there's a lot of stuff in the backlog, or in like in the archives, I guess. There's the YouTube link in the Twitch description. You can go check out all the VODs there. We put up the 2 to 4 segment, or like the feature development segment goes up on the YouTube, but there's also parts of the stream that are not that. So today we were, I woke up and I was like, we need to do USB, and I didn't understand it at all. So we did like probably about 2 hours of like reading spec and stuff. If you want to see that stuff, you either have to catch it live, which is typically the 12:30 to 2 segment, or there's the remaining parts of the VODs go up on Patreon under YouTube members, or on the Twitch VODs get archived, but you do have to pay for those things. Please consider supporting. This content will end when I run out of money, right? And so every dollar that I make while doing this extends the lifetime of this by some unknown period of time. So that's the reason why some portions of the VODs are paywalled, is so that we have something to give to the people who contribute. Patreon, YouTube, Twitch, or if you want to contribute on GitHub, there's no perks from that, but the money that I get is a little bit better. So consider, that's all I ask, but obviously no pressure and no problem if you do not. I think that's all we gotta say. All the plugging we gotta do. YouTube, peace out, and Twitch, let's find someone to raid.